Until now, our videos have focused on compacted graphite iron and engine applications, and that's the core business activity for our company. But over the last few years, we've also used our experience in foundry and process control and precision measurement to develop two new technologies for tracking and traceability. And in this video, I want to talk about our ladle tracker technology. So I'd like to do that with reference to our installation at the Tupi foundry in Mexico. And we can see the process flow in the foundry in this schematic. So we begin with the melting and holding. There are two 13-ton melters just out of view down at the bottom here, and a 35-ton holder. So the iron can start from any one of three different positions. It's then transferred by forklift to one of three different wire feeding stations. We need three different stations to keep up with the speed of the line. And the center station is for the base treatment, and the north and the south stations are for the correction step. After correction, the ladles go to the temperature measurement platform. When the temperature has been confirmed, they can go to any one of the two pouring cars. So it's a normal foundry process. Where it becomes difficult, on this line we produce a small block, and we have a smaller ladle for it, 1,450 kilos. And we produce a larger engine block, and we have a larger ladle, 1,750 kilos. So there's two different ladles. To keep up with the molding line speed, we have 5 ladles in the run. We have 3 forklifts, and we're producing 20 ladles per hour, more than 10 hours per day. So you see that it's a very complicated process. It's a very busy production. It's very high volume. And we all knew, both Tupi and SinterCast, that we couldn't always rely on the operators to take the right ladle to the right place at the right time. So we decided to automate that. And we automated that with the ladle tracker technology. So we placed a radio frequency identification tag on each of the ladles. And here you can see the tag in more detail. And at each of the important positions in the foundry, we put an antenna to read the ladle as it passes by the station. Yeah? And we can put as many antennas as we want in all of the important locations. Here we see the furnace tapping from one of the 13-ton melters. The ladle is on a weigh scale. The RFID tag is on the back. And over here, about 3 or 4 meters away, is the antenna, safely away from the traffic, safely away from the splash, and easily in communication with the ladle tag. It then goes through all of the different steps of the process and ends up at pouring. And here at pouring, we have a green light because all of the steps were successfully passed. And we have the antenna still monitoring the RFID tag for the traceability of the ladle. So what do we get out of the ladle tracker technology? First, it's process control. If a ladle has missed any of the steps en route, when it arrives at the next station, it won't be accepted. Yeah? And so we're ensured that no bad iron gets to the line. We also set control limits, whether it's for weight or temperature or magnesium or inoculant, anything we want for each ladle. And if the ladle is outside of those limits, when it arrives at the pouring car will be automatically locked. We don't have any risk of pouring out of spec iron. We automate this. We don't rely on the discipline of the operator. We can also use the ladle tracker technology for process improvement. You know, any foundry, if you pour 1,000 ladles, you want to move them over to the molding line, and you also want to cast 1,000 ladles. But inevitably, some of them are lost on the way. And we don't always know how many are lost, and we don't always know where or why they are lost. But with the ladle tracker technology, we can track that. So we quantify the ladle fallout, we identify the bottlenecks in the process, and particularly for CGI and ductile iron, we have a pouring limit. For CGI, it's something like 7 or 8 minutes from the end of the correction. So when the correction finishes, we start the clock. When the clock comes to the end limit, we automatically lock out the pouring car. So again, we don't have to rely on the discipline of the operator or the attention of the operator. He may be well-intentioned, he may be well-disciplined, but he can make a mistake. And the automation doesn't make mistakes. All of the data are available to the Foundry. They're automatically streamed to the Foundry database. And for the Foundry manager, he can look at it on his computer in his office. He can look at it on his mobile telephone while he's traveling at the airport. So it's completely available. He can look at it on any internet-connected device. We're doing this in other foundries as well. In the SKF foundry in Sweden, we've put a ladle tag, but also an antenna at the exit of the ladle relining area. So when the ladle is relined, when the ladle is born, it comes out into the factory, and now we can monitor the use of the refractory. Today in foundries, operators look at the ladle for refractory wear, and they decide when to send it in for relining. But with the ladle tracker system, we know how many days it has been since the last reline, we know how many times the ladle has seen liquid iron, and we know for how many minutes it's held liquid iron. And so we can develop rules to optimize the relining process, because refractory lining, it's one of the most expensive things in the foundry. If we can optimize that, it's a huge cost saving. And finally, KPIs, key performance indicators for each shift. So if one shift, for example, is losing 2.5% of its ladles, and if they're losing them at a certain location, we can identify that, we can feed it back to them, we can set a new target, and we can actually measure whether or not they hit the target. Yeah, it's something that we can't do today. And in the foundry, everything that is measured improves, and this allows us to measure more things. The data are all available to the Foundry. At the end of every month, we provide a data summary. I'm not going to go into detail, but it will show how many ladles arrived at each station, where the ladles fell out, what was the condition of each ladle, what was the condition of the liquid iron. We have complete traceability of the liquid metal history and the ladle flow. So it's a really exciting new technology. It's process control, it's process efficiency, and if you want more information, contact SinterCast.